Hi students, so welcome back to the your physics class. So in this session, so we will discuss about what are the necessity of multi-stage rocket as well as basics of angular momentum and the torque fields. In your previous class, we have discussed about how that linear momentum gets conserved in case of your variable mass. In that, we have derived one expression, that is the expression for velocity of the rocket, single stage rocket. So that is what V is equals to V naught plus of it is what it is small v log of m naught divided by what m, which gives the what the velocity of the rocket at any instant of time. So what is the use of having what a multi-stage rocket? So as you know that the rockets are nothing but vehicles which are used to place the what satellite into an orbital motions are nothing but about what it is satellites. Sorry, it's what it is rockets. So these are the devices are the vehicles used to place the satellites into an what orbit called as what is rockets. Okay. So these rockets are based on the principle of what is a law of conservation of linear momentum. So which states that you know it already, the momentum of the system is conserved, so that is remains constant when the net external force acting on the system is what is zero. Okay. So here in our what the last class that we have derived an equations for what the velocity of the rocket at any instant of time is given by what v is equals to that's capital V naught, which is nothing but what the initial velocity of the rocket plus small v, which is your what the exhaust velocity of our hot gases into log of m naught divided by m, where m naught is what the initial mass of that rocket before launching it. Now, so our concept is, so what are the use, what are the necessity of our what it is multi-stage rockets. So if the rocket is having single engine, that one we are calling it as a single stage rocket. So see here what is happening in case of a single stage rocket and the what is use of having a two-stage rocket and three-stage rockets. Let's discuss. In case of single stage rocket, which has only one engine, the fuel mass m is mainly due to the what fuel container, and it cannot be smaller than what is 10% of what is m naught. In the solid fuel rockets, a final mass m may be smaller than this value, that's the m naught, but in such cases, this advantage is what is not useful, or it is what upset by a smaller exhaust velocities v small v, which affects the what the smaller velocity of that rocket. So if m naught by m is equals to what 10 and v naught equals to 0, and the exhaust velocity v is equals to 2 kilometer per second, then in the final velocity, this one you are when you are inserting, when the ratio of what is m naught by m is equals to 10 percentage and initial velocity v naught equals to 0 and the exhaust velocity of your hot gas is equals to 2 kilometer per second, when you are substituting all these variables in where it is in a velocity of a rocket v is equals to v naught plus small v into log of what is m naught by m, then it becomes what? So 0 plus 2 log of is what 10. The log of 10 is 1. So it becomes what 2 into. Now that term you have to convert into what base to the 10. That's fine. It becomes what 2 into 2.303 into 1. There v is equals to you are getting what is 4.606 kilometer per second. So this velocity is smaller than the what? Escape velocity. The escape velocity of any objects from the Earth gravitational field is how much is 11.2 kilometer per second. Hence, in order to get an what? Large velocity, that means we cannot get the large velocity from with the what? Help of a single stage rocket. So to obtain a more velocity or and what? A large velocity than an escape velocity, you are to employ, you are to what? Construct that rocket with what? Two or three engines. So those rockets we are calling it by what? Multi-stage rockets. Okay. So here, so whatever I have told is, if the ratio of your m divided by m naught divided by m is 10 percentage, then the V naught exhaust velocity of the rocket, single stage rocket is 2 kilometer per second. Then V naught equals to 0. Then in such case that V equals, you are getting what? 4 point something. That is in case of a single stage rocket. So that is not sufficient to sufficient for what? Escape from the Earth gravitational field. So the escape velocity of the object is what? 11.2 kilometer per second. So that's why. So from a single stage rocket, we cannot achieve this much of velocity. So for this purpose, so you have to employ, you have to construct the rocket within what? Two or more engines. So therefore, the necessity of multi-stage rocket is to have and what? A more velocity, to achieve and what? More velocity. So let's hear how that multi-stage rockets work, multi-stage engines works inside that our what it is rocket is. Okay. The rockets, if it is your rockets is having two engines, then that one we are calling it double stage rockets. So two rockets are what? Combined together in a series, then that rockets we can call it what? A double stage rockets. So whatever the two engines are there, they're joined in what? A series connections, series connections. So that one we are calling it what? Double stage rockets. So here, first stage is large and heavy, and second stage is what? So small and light comparatively your first stage rockets. Okay. When the rocket is launched, when the rocket is launched into the space, the first stage is used first. When the rocket is launched into the space, the first stage for the first stage rocket starts what? Starts working first. That means the fuel existing in the first rocket starts what? Burning it. That's why the first stage is what? Used first, and its fuel is burned automatically. When the first stage starts, that the amount of fuel existing inside that your first stage engine is starts burning it automatically. It is, and next when its when its fuel comes to an end, it gets automatically gets detached. At the moment, the second stage rockets what? Start working. Start what? Working with the what? The initial velocity given by our what? Our first stage rockets. So now the final velocity of the second stage rocket, the final velocity of the rocket will be nearly twice the velocity achieved by what? A single stage rocket. When you are using what? Single stage rocket, uh, how much of velocity that you have achieved in single stage rocket is double that if you are connected the rockets in what? Two in what? In two its, when that whatever that your rocket double stage rocket is there, the final velocity is what? Two times that of the your what? Single stage rocket is. Okay. Suppose if you consider, if you connected what? A more number of rockets are combined together, are connected together in series, the velocity of the rocket is what? One by one goes on increases. So that is the necessity. That's the use of connecting your what? Multi-stage rockets. So how much velocity? So we require based on that. So we go on construct. We go on what connect the rockets in series. So that is a necessity or a use of connecting your what multi-stage rockets. Okay. So this is about your what the necessity of what the multi-stage rocket to is to have and what higher velocities. The number as the number of rockets are increased, then automatically the velocity of rocket is goes on what is increases. Okay. Next, let's come to the another important concept in case of your what in this session is the angular momentum and what is a linear momentum. So as I said in the first class itself, what do you mean by your linear momentum? What is the meaning of your what linear momentum? So momentum of a body is the what the total quantity of what it is a motion possessed by that objects. Momentum of a body is the what the total amount or the total quantity of motion exhibited by the what object. And this one, how we are measuring? So it is measured as the what by the product measured as the product of what mass of the object and velocity of the moving object. And this one is termed as a momentum. That's a linear momentum. It's, P is equals to what mass into what is velocity. Okay. So this is what it is linear momentum. P is equals to so have it in what m into v. How what it is during motion that object is having a certain quantity of motions. That here that it is what the amount of motion in a body depends on the what the mass and what is the velocity. Whatever that quantity or the amount of motion is exhibited by the body is that depends on what the velocity and what is masses. So that's why the amount of motion possessed by that object what is the amount of motion or the quantity of motions possessed by that object is termed as a quantity called as what momentum and is measured as a what mass of the object and is what velocity. Okay. Now what about your angular momentum? So for angular momentum, this is a simple concept. Again, that's already I think you have learned in your what previous classes. This also. So here that linear momentum means already you know it's the angular momentum is the angular momentum of a particle or an object is a simple one. The moment of it is what the moment of linear momentum of of an object about a fixed point is called as what angular momentum. What is the moment of what is the moment of what is linear momentum of an object about a fixed point about a fixed point is nothing but what angular momentum, or you can define it in reverse form. The angular momentum of particle about a fixed point. That particle is what rotating. The angular momentum of a what object or a given particle about in what a fixed point is the what the moment of a linear moment. The moment of linear momentum is nothing but what is its angular momentum. Okay. So here the angular momentum of the particles about the axis of rotations is given by L is equals to R into P. So we know that P is equals to M into R. It is what M into V. That's why I have written my M outside. Inside that you are having R into M into V. The M is taken outside. So I have inside this one. I have written what R into omega. R into is what V. So for that, how to write that these equations? Suppose if you are consider and what object and a particle of mass m moving about what a fixed point, one fixed point. So that object is what rotating about in what a fixed point. Let r be the radius vector. That means r is what the radius, the distance of that object from your fixed point. So that's why here we are mentioning it as what? That the radius vector, and v is what? A linear velocity of that particles. Then we know that the linear momentum of that particle is given by v is equals to m into v. Next, let's write this angular momentum. That angular momentum is what? The moment of linear momentum of an object about what? A fixed point is nothing but equal what? Angular momentum. So here, the moment of linear momentum of the particles about the fixed point is known as the angular momentum of the particles, and it is given by the what? How we are measuring this one? It is given by the what? The vector product of the what? Radius vector r, and whatever the distance of that particle is there from the center of from the fixed point, the radius vector r, and it's what? Linear momentum. So that's why. So what I'm saying is it is given by the product of vector product of your what is radius vector r and what the linear momentum p. That's r into is what? Okay, and it is denoted by a symbol of S capital N. You can, in some books they have mentioned what is J. It's no problem. It's r into a p. That's equals to m into bucket r into what is v. So here m v r. So by using your the relations between linear velocity and angular velocity, mvr is equals to what? That where v is equals to, we know that's r into omega. This v is equals to what? R into omega, that you are to what? So you insert here. So we're getting m into r omega into r. So that we're getting mr square into omega. Where mr square is nothing but your what? One expression that already you learned in dynamics of rigid bodies. That's the moment of inertia, the product of mass of the object and the square of the distance distance of the distance of the object from the fixed point is nothing but your what it is moment of inertia. I mr square is moment of inertia. So that's why that's is equals to what is I into omega x. Okay. So this is about the what the basic of your which one is angular momentum. Is the moment of what is the linear momentum about a fixed point of a of your what particles and what object is called as it is an angular momentum. Simple one. The moment of linear momentum of an object about a what? A fixed reference point or a fixed point is nothing but our angular momentum. Suppose if your system consisting of what it is some n number of particles, let us write what you have to do is if Z1 and Z2 and Z3 up to what Zn means. So here, if your system is having what n number of particles, m1, m2, and m3, and mn, what are the masses of your particles which are existing inside that your what system, and v1, v2, and v3 up to what vn are the what velocities, linear velocity of the objects, and R1, R2, and R3 are the what the distance of all the particles, the distance of the what all the particles. Then the linear momentum of that first particles, the J1 is equals to what is R1 into P1, R1 into what it is P1 is. Similarly, for your second particles, D2 is equals to what's RP into P2. So that's why the total angular momentum of that system of the particles J is equals to what is J1 plus J2 plus J3 up to what as Gn is. So here I have done again, if you want to write, I have split it here. So R1 into P1 plus of what is R2 into what is P2 plus dash dash of then what n number of particles. So in general, so we can put it like this: summation of what is n is equals to 1 to n what n. This one is what Rn into Pn. When this will give you what the total angular momentum of the what the system of that particles when that system is having what n number of particles. Okay. So next, so that is about even what the basic things. So if your system is having single particles or two particles or any n number of particles, so you can write the total angular momentum of what all the particles. Okay. So after that, you are having one more important concept. So inside that, you are what is Which one? So that is a torque. So torque is also called it by what? Which one it is? Moment of forces. Torque is also called as what? The moment of forces. So let us first in the beginning itself, I will define that's what you mean by your torque. So this is the torque is nothing but an one quantity which is denoted by a symbol of tau. The time rate of change of angular momentum of the particles. What it is? The time rate of change of angular momentum of the particles about a given point is known as what is a torque is. What it is? The time rate of change of angular momentum of a particle about a given point is known as a torque, which is denoted by. So whatever angular momentum is, you know that the moment of linear momentum about a fixed point of that object is called as what? Angular momentum. Here, the time rate of change of angular momentum of a particles about the what? A given point, about the fixed point, so is known as torque. So let's explain so how that torque is obtained. Tau is equals to dj by dt is how it is to be obtained. So we know that consider a particle of mass m rotating about a what? A fixed point. Let r be the, it is what? The position vector, and v is the what is the linear velocity of that particles. Then we know that the angular velocity of that particle j is equals to what? R into p, and r into m into v. R into p, it's a simple one. So r j equals to what? R into p. So when you differentiate this one with respect to t, so you're getting what? dj by dt is equals to what? d by dt into bracket what? R into is what? Up p. Okay. So this one you can put it like so dr by dt. Differentiate for these two terms. dr by dt you keep p as it is, plus you keep r as it is. So into what's dt by what it is? Dt. Okay. So then dz by dt is equals to this is v dr by the rate of the time rate of change of what? Displacement is nothing but what? Velocity. So that's why I written what? V into p is nothing but m into v plus of what? R. So into dv by it is what? Dt. So here according to your vector notations, so v cross v is what? V cross v equals to 0 plus of you are having what? R into dt by dt. So therefore, so tau is equals to this dz by dt is represented by a term called as what? Torque. Torque, so which is named as what? Torque. So dz by dt is nothing but what? Torque, denoted by a symbol of what? Tau. That is equals to what? R into this one is what? Yeah. So therefore, so that's your torque is nothing but in what? The time rate of change of angular momentum of a particle about what? A given point. So is known as torque. That's tau is equals to we are getting what? R into f dt by dt. Simply write what tau is equals to what dj divided by dt. Okay. But this one we can put it like this as torque is equals to R into F. So we know that according to your Newton's second law of motions, the time rate of what? The linear momentum. This one is the time rate of what? Linear momentum is nothing but what? Applied force. dt by dt is nothing but your what? Applied force. So therefore, this torque is equals to what? R into this one is what? F. This dp by dt is nothing but what? The time rate, the rate of change of linear momentum, the time rate of what? A linear momentum is nothing but what? Applied force. So your equation reduces to what? Tau is equals to R into F. So here the torque is equals to means what? Is equals to the moment of the force about the given form, about the given point. So from this, what you want to conclude is the torque is equals to what is moment of the force about a given point. And here the torque is a vector quantity. Torque is a what? Vector quantity. And the SI unit of your torque is what? Newton meter. The SI unit of your what? Torque is what? Newton meter. So here for force is Newton. For distance, that's R is what? Meter. That's why what? Newton meter. So in this class, so we have discussed about what the necessity of what multi-stage rocket and the what are the basic things existing in what angular momentum travel and what it is at. Okay, thank you.